Okay, we are going to solve the system using Cramer's rules. So section 3.7 day 1, we talked about Cramer's rule for 2 by 2 matrices, which is what we're going to do for example A. So the first thing I like to start with is color coding everything. So our coefficients of x are going to be 1 and 2, and they're going to be pink. Coefficients of y are 2 and -1, and they'll be orange. And then 4 and 14, our constants, are going to be yellow. So you need to memorize your formulas for d, dx, and dy. D is just your regular plain coefficient matrix. So your first column represents your coefficients of your x's, 1 and 2. Your second column represents the coefficients of your y's, 2 and -1. Your dx matrix, you swap out your x column. Remember, our x column was the 1 and the 2. You swap out your x column with your constants, 4 and 14. So instead of starting with 1 and 2, we start with 4 and 14. Our y column doesn't change though, so we stay to -1. Now for dy, you go back to your original D matrix. You swap out your y column, because it's dy, with the constants 4 and 14. Your x column goes back to 1 and 2. You need to know that for the quiz. So now we find the determinant of each. So we take -1 minus, and then 2 times 2 is 4. So our D matrix determinant is -5. Our dx, we take -4 minus -28, there we go, and we get -32. And our dy, we take 14 minus 8 to get 6. So your x coordinate, remember we're solving a system, so we get an ordered pair where our lines technically cross. Our x coordinate is going to be x equals dx over d, y equals dy over d. We need to know this for the quiz. Dx we just found to be -32. D was -5. Negative divided by a negative is a positive 32/5. Our our y value, we're going to take dy over d. Well, dy is negative, just kidding, it is 6 over -5, so it's a -6/5. And our final answer we have to write as an ordered pair with parentheses. Now in example C, we have a very similar process. We just have to take the time to do it with 3 matrices. Now remember, solving using Cramer's rule for 3 by 3 systems, we will do on our graphing calculator. So make sure you've got that handy if it's not already. So the first thing we'll do is we'll rearrange and put everything in standard form to make our lives easier. So that first equation, we've got 3x's, we've got a -3 in front of our y. We have no z's, so I'm going to go ahead and write that in so that we remember it. Our second equation, we have to add the 3x to the other side and the 3y. So we have a positive 3x, a positive 3y, and 1z. All that was left on the other side was the 9. Our last equation, we have -4x plus 5y plus 1z equals 8. That guy was fine to begin with. And we set up our 4 matrices this time. So your D matrix is your coefficients of your x's for your first column, coefficient of y's for your second, coefficient of z's for the third, and your constants will be used to find dx, dy, and dz. So we've got 3, 3, and -4, -3, 3, and 5, 0, 1, and 1 for your last column. Again, those are just the coefficients of x, y, and z. Your dx matrix, we swap out our x column with our constants, the -6, 9, and 8. Everything else stays the same, -3, 3, and 5, and 0, 1, 1. Then for dy, now we swap out our y column with those constants. So that's the first thing I'll write. -6, 9, and 8 goes in the middle this time. And then your x column stays the same, 3, 3, -4, and your z column stays the same as well, 0, 1, 1. Lastly, we'll find our dz matrix, where our first column stays 3, 3, 4. Our middle column goes back to our coefficients of y, -3, 3, and 5. And it is our third column, our coefficients of x, that get swapped out with -6, 9, and 8. Now, we calculate the determinants of all of these by using our graphing calculator. And to do that, make sure you see the other video that I posted. But for now, we'll jump to the conclusion. Our determinant of matrix D is 15. Our determinant of matrix DX is also 15. Determinant of matrix Y is 45. And determinant of matrix Z is -45. So your x coordinate you find by taking dx over d. So our x is going to be 15 over 15, which is 1. Our y coordinate, we take dy over d. 45 over 15 to get 3. Z, we take dz over d to get a -3. You have to write your answer as an ordered triple this time. So 1, 3, and -3. Final answer. You will have problem, what example are we on? 8D for homework. Okay, and then we've got our last example that we are going to work through together. So in example 9, you're canoeing down the Boundary Waters, and notice how strong the current is. You traveled 210 miles downstream and back. The trip downstream took 10 hours, trip back took 70. What is the speed of your canoe in still water, and what is the speed of the current? Well, this is going to be a distance equals rate times time problem. So we want to let x and y stand for the speed of you in your canoe, and y can be the speed of the current. And that is just always the pattern that we follow, I guess, when we set up our distance equals rate times time problems. Notice that's also what we're asked to find. What is the speed of your canoe? Oh, good, that's one of our variables. What is the speed of the current? Great, that's the other variable. Then our distance for both of these, whether you are traveling downstream or upstream, your distance was 210 for both. So distance equals your rate. When you are traveling downstream, the current is helping you, so we add x plus y. When you are traveling upstream, you subtract. Then distance equals rate times time. Let's see, so downstream took us 10 hours, upstream took us 70. That's right. And there are our two equations. Now, before we use Cramer's rule, we have to put these in standard form so that they look a little bit better and fit into our matrices nicely. So our first equation we are going to rewrite as 210 equals 10x plus 10y. Note that you also could have divided both sides by 10. That also works. And our upstream equation will be 210 equals 70x minus 70y. We set up our three matrices. We have our D matrix, which is just our coefficients of x. Now, don't be afraid that our equals is on the other side and our constants are on the other side. That's okay. Our coefficients for x are still going to go first in our dx matrix, 10 and 70. Our coefficients for y go next in our next matrix, 10 and -70, or in our D matrix, excuse me, I can't remember what I said. Then we've got our dx matrix where we swap out our x column with our constants, 210. And then your y column stays the same, 10 and -70. And then we've got dz where we swap out our z column. So we go back to our coefficients of x for our first column, 10 and 70, and then our second column, 210, 210. And we calculate each of these determinants. So our D determinant is -700 minus an additional 700, so we get -1400. dx, we are going to multiply 210 times -70. We get -14,700. And we subtract, always subtract, 2100. So we get -16,800. It's okay if these are giant numbers. And then dz, we take 2,100, and we subtract the 14,700 in order to get negative 12,600. Remember, to find your x, you take dx over d. So we are going to take negative 16,800 divided by negative 1,400. Well, your negatives cancel out. The speed of your canoe is 12 miles per hour. And the speed of the river, or of the stream, wherever we are, boundary waters, we take dy over d. We take negative 12,600 divided by negative 1,400. The speed of the current is 9 miles per hour. So sure enough, you are barely going faster than it, barely going where you want to go. Alrighty, so you will have example 10 for your homework, and then know that you can check your answers to each of these on the key on Google Classroom.